let us discuss about the program that was written for counting, for up counting as well as for down counting using the behavioral model. Here, uh, n is going to take the value as that is given in the test bench. N is going to take the value as 4 bit of 0, 1, 1, 1. Means 2 power 0, 2 power 1, 2 square and 2 power cube. So its decimal equivalent here is 4 plus 2 plus 1 means 7. Decimal equivalent is 7. So let us come to the program now. N is going to take the value as 4 bit of, in the test bench, the value of N is defined as 4 bit of binary 0 followed by 3 ones. Nothing but its decimal equivalent is 7. Now coming to the module here, module name is user defined. A is the output of the counter. Clock, counter is nothing but group of registers. Register nothing but a flip-flop, which is a storage element. So we are going to, the basic element of this particular thing is a flip-flop, which is a sequential circuit and which is operated with the help of clock signal. So we are going to have the clock here. Then n is the final value up to which the count has to be taken place. Either the count is starting from 4 zeros and ending with n value, means 0001, 0010, like that and so on. And if it reaches up to 0 followed by 3 ones, then we can call this count as up count. It is incremented every time. For every clock pulse, it is incremented by 1 bit. So this is up count. And when the count is starting from 0 followed by 3 ones, then 7, 6, 5, the decimal equivalent I am going to say, 4, like this. It goes on and finally it reaches 4 zeros, decimal equivalent 0. Then this type of count, you can call it as down count. So when it is decremented from one level to other level, it is decremented by 1 bit. So this count, we can call it as the down count. So to define from where it is starting and where it has to end, that ending point in up count, we can call it as n, and the starting point in down count, we can also call it as n. That is the starting point and ending point is 0. Whereas in up count, the starting point is 0 and ending point is 7. So 7, it is represented in the form of 4-bit data, in the form of a vector 3 down to 0. Here, the input clock, it may be positive edge clock or it may be negative edge clock. So clock is defined. It is going to take either positive edge, means changing from 0 to 1, or changing from 1 to 0 if it is edge triggering. Then we are going to have a control signal called as U underscore D. It's the control signal. Based upon this value of control signal, U underscore D, if U underscore D value equals to 1, then up count is going to be taken place. If U underscore D equals to 1, then up count will take place. And if U underscore D equals to 0, then down count operation will be performed. So this is the control signal which says whether the counting is up count or down count. and A is the final output. As we are going to have the N is defined as the 4-bit data, output is also of 4-bit data. So this output is represented in the form of register since it is written in the behavioral model. Why? Because we are going to see the statements as initial statement and always statement. We can say it's these two statements are written in the behavioral model, and when we are going to see this statement, it belongs to the data flow modeling. So it's the mixed combination of this program is the mixed combination of behavioral modeling and data flow modeling. So initially we are making the output before giving any input. All the contents of the flip-flops must be cleared off. Whether to have the up count or down count, that will be later decided. But initially the counter was cleared. So that's why the output of the counter is A. We are going to assign zeros. All the contents of the 4 flip-flops are zeros. So A equals to 4-bit of binary, 4 zeros are assigned to 4 flip-flops. Now, using the always statement, always at the rate means change. Always at the rate negative edge clock. As already said that we are going to have level triggering and we are going to have the edge triggering. So types of edge triggering are positive edge triggering and negative edge triggering. Positive edge triggering means if a transition is going to be taken place from 0 to 1, then we can call it as the positive edge triggering. And if the transition is going to take place from 1 to 0, we can call it as negative edge triggering. So here in this particular program, the changes in the counting operation is going to be taken place for every negative edge triggered clock pulse. So for every negative edge triggered clock pulse, we can see the change in the counter, whether it may perform up count by 1 bit or it may perform a down count by 1 bit. Now, coming to the key statement in this particular program, which is written in this particular statement is written in data flow modeling using the conditional statement. First, whether to have the up count or down count, that will be decided by u underscore d. So that's why that condition is written before the question mark. So before the question mark is the condition, u underscore d means it is going to take the value as 1. If u underscore d value equals to 1, then very next statement after the question mark will be assigned to A. Else, if this condition is not satisfied, u underscore d is equals to 0, then after colon, whatever may be the statement is there, that will be assigned to A. So that is the meaning of this particular statement. So first of all, it is checking whether u underscore d is 1 or 0. So you can give this option of u underscore d in the test bench, whether you can make it as 0 or you can make it as 1. So let us see, for example, u underscore d value equals to 1. If u underscore d value equals to 1, then this part of this particular thing is going to be assigned to A. So when we are going to observe this part, again there is a condition. So before the question mark is the condition saying that that condition is A equals to N. So A was taken as 4-bit of 4 zeros and N value is already defined in the test bench as 0 followed by 3 ones. So these two conditions, are they equal? No. Since these two conditions are not equal, then what happens? A will be, if it is equal, then 0 will be assigned to A. If this condition is not satisfied. Means A will be incremented by 1 bit of 1. Now, let us take the example that U underscore D equals to 1. When U underscore D equals to 1, then this particular thing will be assigned to A. Coming to this particular statement, again it is having a condition, checking for the condition A equals to N. So 4 bit of 0 is not equivalent to 0 followed by 3 ones. So that's why this condition is not satisfied. Then whatever may be the thing after colon will be assigned to A here. So what happens? A will be incremented by 1. So initially A was 4 zeros. Now it is incremented by 1. So what happens? 4 zeros added with 1 becomes 0, 0, 0, 1. So now A is going to take the value as 0, 0, 0, 1. Again, it is checking with this condition. Okay. So 0, 0, 0, 1, it is not equals to 0 followed by 3 ones. 1 is not equivalent to 7. So the condition is not satisfied. Again, what happens? Again, it will be incremented by 1. So it is going to take the value as 0, 0, 1, 0. Decimal equivalent to 2. Again, this decimal equivalent to 2 is not equals to n. N is 7. But A has been incremented to 2. So condition is not satisfied. Again, it will be incremented like that. It goes on until A equals to n. So when A equals to n, what happens? Means at last, the last count will be 0, 1, 1, 1. 3 ones. So here, in this particular condition, A value becomes equals to n. When A equals to n means the condition is satisfied. When the condition is satisfied, very next to question mark will be assigned to A. So the content of A will be equals to 0. The content of A is nothing but 0. So here we observed that when U underscore D value equals to 1, again it is checking whether A equals to N. If not, A will be incremented by 1. So this particular count is going to be taken place. And this count we can call it as up count. Similarly, we can explain what happens when U underscore D equals to 0. Means U underscore D, whatever may be the condition before the question mark, is the condition. If U underscore D is not equals to 1, means it is equals to 0, then after colon means this statement will be assigned to A. When we are going to come to this particular statement, it is A. A is actually 4 bit of 0. So it is matching with the 4 bit of 0. The condition is satisfied. Then what happens? N will be assigned to A. So what is N here? 0 followed by 3 ones is N. Else means what? Again. So now A is going to take the value as N, nothing but A 0 followed by 3 ones. Now this A is again checked with 4 bit of binary zeros. So 4 bit of binary, 4 zeros. So 0, 1, 1, 1 is not equals to 4 zeros. Condition is not satisfied. Thereby, if condition is not satisfied, whatever may be the thing after the colon will be executed. After the colon, what is going to happen? A is decremented by 1 bit of binary 0. So, A is, first it is going to take the value, condition was sat, in the first case, condition was satisfied and N is assigned to A. So, this N is assigned to A. In the next case, A value is 0 followed by 3 ones, nothing but 7. 7 is not equals to 0. Condition is not satisfied. Then A will be decremented by 1. A is decremented by 1 means the value becomes decimal equivalent to 6. Now A is going to take the value as 6. Again, it is compared with 4 bit of zeros. The condition is not satisfied. Both are not equal. Again, it will be decremented by 1. So, it will be 5. And so on. And at last, the last count becomes 0, 0, 0, 0. And this 0, 0, 0, 0 is again compared with 4 zeros. The condition is satisfied. Again, it goes to n. So when you are going to observe this count is nothing but down count. In this way, we can write a program, a complex program for up and down counters in a simple way with the help of behavioral and data flow modeling statements.